Hi, I'm Alex. I'm excited to be talking about our light characterization and optical testing capabilities at Sherpa. Many of our products require designing sensor packages that capture and process light across the spectrum. In some cases, we create pre-production units for testing and field application. To ensure consistency and accuracy, we use advanced optical tools such as polychromator and monochromator light sources. These instruments allow us to characterize a reference unit, which then serves as a benchmark for subsequent units. This meticulous process allows us to ensure accuracy and consistency in our work. So one of the ways we characterize a reference unit, and that way we can describe how it functions against real-world values, such as irradiance, is to measure the frequency response of the device. So this unit here is specifically focused on measuring the frequency response. It's called a monochromator. And so its job is to pipe in a light source. In this case, we're using a halogen, QTH. It's going through a filter wheel to pre-filter it so that we're narrowing it down to the specific range of light that we're interested in. We have slits to make sure that we can cut out the actual frequencies down to about plus or minus 10 nanometers, or depending on the slit, we go down to plus or minus 5 nanometers in the wavelength. And then it's going in, it's being filtered, redirected into an integrating sphere to diffuse it, and then we're concurrently measuring the device under test, which would be the reference device, and a silicon photodiode. So we can, in this case, we're setting ourselves up to measure all the way from ultraviolet to infrared. So somewhere around near UV, so 350, all the way up to about 1100 in the near infrared range. So next we're going to talk about the polychromator. So this is a light simulation. Polychromator just means a wide array of light. So its job is to simulate different lighting conditions. We have a light source here which puts in, it's basically an array of different LEDs so that it can control different light bands. And then it pipes it into a device that filters and diffuses it with a port so that you can read in front of it. So this device lets us simulate different types of visible light. It lets us simulate cold white fluorescent, compact fluorescent, cold white LED, standard luminances like A, B, C, D65, and it lets us focus on typical screens like an RGB screen, or focus on a specific light frequency like orange. So the control software for the polychromator lets me go in and set to different types of light sources. In this case, I'm setting it to a luminant C. I can set it to specific colors like blue flower or something like that. And then it will set the target, and then the polychromator will adjust its micromirrors and intensities of the LEDs to simulate whatever curves that I ask it to produce. Okay, we'll go ahead and turn on the polychromator, and that way we can do testing with it. So I'll turn the lamp on. So in this case, I'm going to tune it for room lights. So the yellow target is what would look like a typical room light. The purple curve is the actual light being received by the polychromator. And so what it's doing is it's going through iterations as it's trying to get the actual light, the purple curve, closer to the yellow target.